In Algebra 2, section 6.7, we're dealing with solving radical equations. Now, we're not only dealing with radical equations, but radical inequalities. You might be faced with something called extraneous solutions, which basically is a solution that you get at the end, but when you plug it back in, it doesn't make the value true, so therefore it is not a solution. But what you're dealing with basically is equations with radicals in it. Now, I can't solve the opposite of a radical or square root or cube root or whatever the currency is, whatever root it is, the nth root, is I can't solve it unless it's first isolated, because the opposite of a square root, for example, is squared. But if I were to square this like this, what would happen would then be I would end up with square root of y minus 2 minus 1 times square root of y minus 2 minus 1. I have to do parentheses because there's that minus there. Now, if that minus wasn't there and I can just square root, then it would cancel out that square root. So, to make my, not that I couldn't do that, but to make my life easier, I'm going to first isolate the radical. So I'm going to get rid of negative 1 so that the square root is by itself. And I do that by the opposite, which I add 1 to both sides. I end up with square root of y minus 2 equals 6. Now I can square both sides. So if I square this, and I square this and this cancel out, leaving me with y minus 2. 6 times 2 is 36. And then I'm going to add 2 to both sides. I end up with y equals 38. Right? Now, number 2 forces my hand because I do have a 2 here, but because I have a square root on both sides, I can't really do anything about it. So because I can't square without affecting this. So I'm going to be forced to square it anyways. So this means that if I square this, this automatically cancels out, giving me x minus 12. But this, because it has a minus between my terms, I have 2 different terms and one of them square root, I have to do 2 minus square root x times 2 minus square root x, right? So if I'm focusing on just this, this is 2 times the whole thing, because I have to distribute, times minus square root x times the whole thing. Okay? Which then leads me to 4 minus 2 root x, right? Minus 2 root x, and then minus x. This together becomes 4 minus 4 root x minus x. While on this side, I just bring it straight down, x minus 12. Now, because the square root is on one side, I can then isolate like I do here. So I'm going to add x to both sides, and I'm going to subtract 4 to both sides. This gives me 2x minus 16 equals negative 4 square root x. Okay, I see the mistake here. So what happened here was that I multiplied this times this, which should have given me a positive x. So this is positive, so I would have had to have subtracted x, which this cancels out, leaving me with negative 16. Then I divide by negative 4. Divide by negative 4. My negatives cancel out. 16 divided by 4 is 4 equals root x. And then I square both sides, giving me 16 equals, because this cancels out, x. Sorry about that. So that one was a little longer because I had the square root on both sides, so I didn't have the same option here of just isolating it. But once I square it, then I end up to the point where I have a square root only on one side, and then I can isolate it and then do the same method. So go ahead and pause and write this down. you might want to check the answers in case this is an extraneous solution. So basically, if you plug it back in and it doesn't give you the answer that you need, then it is called an extraneous solution, so it doesn't work. Not all the ones you're going to be dealing with is square root. This one, for example, is cubed root, but the method is the same. I'm going to isolate the root, the nth root. So I'm going to subtract 5 from here, right? And then I do the cubed root of 3y plus 1 equals -5. And then I'm going to, now if this was the square root equals -5, there's never anything that you're going to, it would be no solution, because no matter what squared, you're not going to end up with a -5. I'm going to cube root this. I'm going to cube it. This will then cancel out, end up with 3y plus 1. This will be 5 times negative 125. And then minus 1. 3y equals negative 126. And then, sorry, I don't have a calculator. 42. Y equals negative 42. So the method is the same. We're going to isolate. The only difference is you're going to be cubing, or whatever root it is, that's what you're going to be doing the opposite side in order to cancel out. I can't square both sides because then that doesn't cancel this out. It just complicates the problem. What we're dealing with next is equation of a radical inequality. So we're dealing with equations similar like this, but they're going to be inequality signs. So these are the steps that are going to have it, because it's a little bit tricky. You're going to, the rules are the same. When it deals with inequality, you treat it just like an algebra equation, except when you multiply or divide by a negative and then you flip the sign. But when you're dealing with roots, you also have to make sure that if you're dealing with a square root or an even root, that you don't end up with a negative on the inside. So it has to be bigger than 0. Because if you end up with a negative on the inside, then you can't square root it. You deal with imaginary numbers, and you can't solve an equation with imaginary numbers. So we have the first step. So write this down when we do the next problem. The first step is to solve when the inside of the radical is greater than 0. First I have to know the minimum. Okay, what number can it not be in order for what number can it be so that it can be greater than 0 on the inside of the radical? Then I'm going to solve it just like I would solve any inequality. I'll solve it just like this, except when I multiply or divide, I'm going to flip the sign. And then I'm going to use solution 1 and 2 to find the overlapping solution, right? So again, pause, write this down. I have one more board for you. Okay. So in this one, we have a root. My first step, it tells me that I need to solve, so I'm just going to focus on this square root. Okay, so my first step is to do square root of 3x minus 6, and when it equals 0. Okay. Then I'm going to square both sides. I end up with 3x minus 6 equals 0. Then I'm going to add 6. And that cancels out. 3x equals 6. And then divide by 3. End up with x equals 2. So I need to know when x is bigger than or equal to. Sorry, so not equal. This has to be greater than or equal to 0. Greater than or equal to 0. And because I didn't multiply or divide by negative, I don't flip the sign. So x has to be bigger than or equal to 2 in order for me to have a positive number in that square root. So this is the first part of my solution. So my next part is to just solve it like I would normally solve it. Square root of 3x minus 6, and then plus 4 is less than or greater than or equal to 7. I'm going to solve like I did. I'm going to isolate the square root. So I'm going to subtract 4. I end up with square root 3x minus 6 is less than or equal to 3. Then I'm going to square both sides. This cancels out, giving me 3x minus 6 is less than or equal to 9. Add 6. I end up with 3x is less than or equal to 15. Then I divide 3 on both sides. I end up with x is less than or equal to 5. So 3, the last step, is I'm going to take these two answers on the timeline. So here's 2, here's 0, and here's 5. So the first one is x has to be greater than or equal to 2, but it has to be less than or equal to 5. Right? So that means my answer has to be between 2 and 5. So x has to be bigger than 2, but less than 5. And that's how I write it. Okay? So go ahead and write this down, page 432, numbers 8, 10, and 18. 432, numbers 8, 10, and 18, and I will see you in class.